my co-speaker.
Hi, I'm Tim. You guys met me earlier.
You met him earlier. Sorry I missed the earlier talk. We kind of worked both of these in concert, but Service Mesh Con wanted to hear what NSM was, and Network Service Mesh, so I had to do a lightning talk over there quickly to give a plug of what you guys are doing here and what we're doing versus what they're doing over there in Service Mesh Con. So this focus here is more on a demo than anything else. And I want to point out it's really layered on the top of the earlier presentation and the earlier work that Tim presented. But what we're going to do is basically show how Istio works with Network Service Mesh. So how we're going to basically put an Istio mesh on top of a Network Service Mesh virtual L3 connected topology. So in this case, it's a little simpler setup than what Tim showed, in that we're using just 2 local clusters. So we're not using public clouds, keeping it a little simpler. But the idea, of course, is, as you know, Network Service Mesh is here to provide us a lot of sophisticated layer 2, layer 3 networking options in a cloud-native way. While probably many of you are familiar with application service meshes and Istio, Linkerd, they are a little further up the stack, providing a little bit more functionality and capabilities, especially at layer 7. So what we think this provides is a very rich full stack experience for the developers. They can do very sophisticated things at layer 2, layer 3, and yet they can also achieve the very sophisticated layer 7 experience that is their bread and butter. So why should you care? I think in a lot of ways this slide is unnecessary for this audience, but it's really focusing on for hybrid cloud environments, how we can have many different options to handle connections across those environments and how to manage those connections. And very frequently in those environments, you have security teams, your SecOps or your NetOps that will put very sophisticated or very difficult requirements in order to communicate across those environments. And NSM allows a simple way for the developer to request services that meet those requirements and not have to be dealing with the complexity of that setup. While Istio itself, or the application service mesh, sort of goes to the next level of being providing very sophisticated security, retries, logging, tracing, all sort of at the layer 7 application layer. So is everybody here familiar with application service mesh? Is anybody not familiar with application service mesh in Istio? Okay, I can pretty much skip over these slides, and this was just a little bit of an introduction to Istio. So what we're going to do now, we're going to actually try to do a live demo. I have a video recording if it falls apart, and unfortunately my lab systems restarted overnight, so I hope this works. But I'm going to try to do start and install here to see if we can get this working live.
So what John's going to do is just take a set of scripts that I showed you earlier, but just install those on a local set of clusters. And so NSM, and we'll come up on those 2 clusters.
Oh, a lot of latency here. This might not work due to latency. Oh, it's really slow.
All right, yeah.
Okay, so first thing we're going to do here is install Istio in cluster 1. You can see that it's going away and installing Istio. It takes a while. Istio has a lot of shit it's installing. A bunch of CRDs.
Still going.
Now I'm installing in cluster 2.
So what version of Istio are you running?
This is version 1.3. Just they're at 1.4, but we use 1.3 just to keep it consistent. Sorry about the delay. The latency seems to be really bad here.
It's a live demo.
The joys of a live demo. Any questions?
Is this live? Is there any specific reason why you are installing Istio first than NSM?
No, it's not really.
Because it takes a longer time, I think. You should have.
So now I'm installing NSM, and you can see that NSM is so much quicker here. There's not as much shit that NSM is installing.
It's all relative.
So
Well, Istio has some dependencies on order of things that get installed, so they do a little bit more, and they're more productized. So it's got a little bit more. They also have a lot more services. So.
And now I'm actually installing the application, the network service client, and network service endpoint. We're going to do this. This also takes a while, so we'll go back to the talk here in a second and come back to the second cluster in a minute. So let's go back to the talk. And Tim, why don't you take it away?
Sure. Yeah, so I'm going to basically go a little bit through some of the same content that I went through earlier, but in slightly different detail. So like John was saying, we're layering the application service mesh on top of the network service mesh with the virtual L3 NSE deployment. So we're leveraging that same thing that I showed earlier with the DB replication, but this time with Istio workloads, meaning like applications that are running with Istio sidecars, Envoy sidecars, and controlled by an Istio control plane. So the NSM plus the virtual L3 is providing the virtual networking, the network connectivity between the workloads that are in this scenario. So when we have, so what the final topology would really look like is something like this, where we have the workloads that are joined to the virtual L3 as clients, so the virtual L3 network service. They would actually be part of an Istio service mesh, the same Istio service mesh across clusters. And in doing that, we're using, logically, we have kind of the same Istio control plane. I mean, we actually have multiple installations of the control plane, but it's logically the same control plane because we're configuring it identically. So this model is the sort of what works out of the box, and that's your typical workload Envoy sidecar of your workload pod model. And so the V-wires that are connecting the client workloads to the NSEs are connecting that whole pod which has Envoy already included in it. There is some thought and work going into having Envoy be outside, so it's a separate pod and like a separate network service in the chain. That's not what we're demonstrating, but that is an idea that we're trying to work through a little bit.
And two points on this. One, there's been some work in the Istio community to have this type of model where Envoy is outside of the pod. But there's also, I heard Ed and others here mention the possibility of having Envoy be a service that you a network service that you use to install in the data path. So that would be, this model is akin to having Envoy itself be a network service that's NSM controls.
A network service endpoint.
Network service endpoint.
So remember, a network service is a collection of one or more network service endpoints that are providing the service to clients. So if you had this model, Envoy would be another network service endpoint in the same network service as the virtual L3 network service endpoint. Right, yeah. So the Envoy interceptor model, so Nikolai just said that there's in the examples repo, there's an Envoy interceptor, I think Frederick did it, that has this, an example implementation using this model, meaning like the Envoy is a network service. I don't think there's two network services in the chain, are there? Or network service endpoints in the chain, that's one, yeah. But it could be extended easily to that. But I think there's some additional work that would have to go into the Istio integration to make this work. Yeah, sorry, that was a big segue. So anyway, Istio layered on top of NSM. Again, this is our topology with two clusters. You have your application pod with its app container, workload container, and then we would have Envoy sidecar gets injected by the Kubernetes, by the Istio admission webhook, and that ends up when we make it part of the virtual L3 network service, that also gets injected with an NSM init container that causes the request for the network service to happen, and then the data plane for the connection between the application pod and the virtual L3 network service endpoint gets created by the data plane. And in parallel, the virtual L3 network service endpoint is going to connect to his other network service endpoints that are making up that virtual L3 private network, and create this middle connection here, and that would allow the actual other client workload, when it connects to the other network service endpoint, to gain full connectivity across from workload to workload. And then so what I just showed was that's the end result data plane. The control plane that carries it out looks like this. You guys saw this earlier. So it's basically there's a control plane component to all of these things in this, the application pod, which is that NSM init container, and then the data plane has an interface to the network service manager that it's providing, and similarly the network service endpoint is providing an interface as well to terminate connection requests. So when we layer Istio on top, we have this is how we integrate the Istio control plane on the two different clusters. So Istio multi-cluster has, or Istio pilot has the capability of discovering service information from multiple clusters already. It doesn't really work if you don't have connectivity between those clusters. But the thing that doesn't happen right now is that pilot can't see any information about the network NSM interface information. So what we did was create what we call in this slide an external service registry, and that thing knows the interface information about all of the interfaces that are plugged to application pods in these two clusters or in multiple clusters. And so what we've done is pair pilot with service discovery from this external service registry as well. So that's how our Istio control plane knows about NSM data paths. So the envoys on both clusters will get configured properly to use the NSM virtual L3 connection. And this is all together, the eye chart. But yeah, what this is really just trying to differentiate what the data plane and how much control plane interaction there is to just get this data plane working. And it's very layered, right? So you have the Istio logic. There's only one component that's integrating the data from the NSM control plane with the Istio control plane. So for what is the pod? What actually happens inside the pod for the application? This is an attempt to describe that. We have on the left side is the application container we all know and love. And then on the far right bottom, there's the CNI interface that Kubernetes plugs. In between there, with the normal Istio case, you have IP tables, and we represent it as 2 blocks, but really, so you have IP tables and you have routing stages in the IP tables workflow, but you're able to manipulate how the networking stack functions by programming IP tables, and that's what Istio does. We don't do anything different. We just leverage that.
And the real reason we had the route, we separate the route even logically, it's part of IP tables, as Tim was saying, but we separate it out because really within this use case or this demo, the only piece that NSM needs to touch to make this work is the route piece. So yeah. it just inserts a few routes. Then Envoy just is able to use those routes. The Istio IP tables, what Istio does with IP tables is unchanged. So it's just that route block is the only thing that's a delta between standard Istio and standard NSM.
So, I mean, you could think of all of these little lines in this picture as actually they're implemented by IP tables. So the connectivity between the application container and the Envoy sidecar is actually because IP tables is manipulating the traffic where it's going. And similarly on the inbound, the Envoy is in between the application pod container, because of the manipulation as well. But the key point that John said, though, is the route table is really the only thing that needs to be manipulated after this to use this NSM interface. After that, Envoy just needs the rules to be able to map traffic to those route targets. So for service registration, this is the workflow of how we implemented that service discovery hook that we added. What's happening, what this is trying to describe is that we use we have the normal application pod discovery that watches for, this is like the model is the same. It watches for pod events, and it discovers the Kubernetes information about the service, and then populates this external registry, or goes and discovers the NSM interface information, and then populates this external registry with that service content mapped to those NSM interface endpoints, and that's consumed by Istio Pilot in the same way that Pilot consumes from another cluster, actually. So it looks to Pilot like this is kind of like a multi-cluster model, but the only thing it's really getting is NSM-related information from what we populated in that external registry. And we implemented that with a kind cluster, so we can have that as the Kube API be the interface that Pilot leverages because it's already implemented. All right.
Okay, so now we'll try to get back to the demo. First thing I'll do here, though, is kick off a little bit more of the script so it doesn't slow us down too much. Okay.
Started at the top.
Oh.
Just for recap.
Okay, so this is the precise topology that we're showing here. We only have two NSE vRouter, two NSEs that are acting as virtual L3s. The two clusters are actually two bare metal clusters that I use locally. We're keeping it pretty simple. Again, it was based on the stuff Tim showed you earlier. So we have four application pods here. They're all running the Hello World application. I kind of kept it simple. So we'll see the difference in these based on the pod names as we go through this. And the application service mesh is shown extended or stretched across both clusters, including all the envoys. So the actual sequence I kind of went through just to recap in bullets since it might have been hard to see. I deployed the Istio control plane, then I just deployed the NSM control plane. I just deployed the NSE and the NSEs and the application. This is the step we're at now where we deploy and populate a service registry. Before we do this, because this is the key part that actually ends up getting the NSM endpoint to service topology information into a registry, which then is read by Pilot and then pushed to Envoy. So before we do this step, we'll see that things don't really work as we'd like them to. So I'm going to jump here and show you that, and hope this isn't too hard to follow through. Did this? Let me see here. My windows are a little screwed up, but so if we look at the different pods, hopefully this is all up, or I'll have to go back to the video. This is the all the Istio system is up. This is the NSM components. This is the actual application. In this particular case, you can see that the application has 5 containers in it. Those containers one is the actual Hello World application. Another is more or less just a tools container I use to be able to run some tools. Then there's 2 NSM containers. There's the NSM init and the, oh, I'm sorry, not the init. The init container ran, but there's the NSM DNS container and the NSM DNS monitor container. That gets us to 4. And then the 5th one is the Envoy sidecar container. So those are the 5 sidecar containers. I can show you that if you're interested, but trust me, I guess. And going to look at the other container, the other cluster. And hopefully everything's up there. And everything there is running too. So now if I kube exec into one of these containers, we'll see that we're able to ping because NSM has happily created everything, but we're not able to curl. Oops. I do that quite a bit. I did that too.
We can pair program. I can use left hand.
Okay. If we ping 10.60.160.1, I cannot type. I should go to the video. So there we got that. I'm going to guess at the addresses here a little bit. So, no. Sorry, I'm guessing at the addresses a little bit here. I can skip that one. That's on one of the other clusters. You notice that it's 154 address. And that's the other one. If I curl the local host, this will work.
But you
Oh.
in the container you want to go to because you need to put minus IT on it.
Yeah, I'm in one of the containers.
Yeah, but when you did
Oh, it
the
looked like
exit,
you're out.
I exited. How do I do that? Sorry.
You gotta do minus IT.
See, I can't type. That's why I do the videos. Okay.
So that's pinging between NSM.
Now it works. Okay, well, trust me that the pings work in the interest of time. I'll show you the curl does not work. So this curl will work because I'm just doing it from the local host. But if I try to curl, for example, this address.
So the pings worked. Envoy doesn't intercept ICMP, so you just.
Oh yeah, that's a key point.
So the pings work, but the L7 curl stuff doesn't work.
The curls won't. So
because
now
the Envoy rules aren't set up.
So now if we go here, and I'm going to install the two registries. This is the watch. This is a pod watcher that we wrote. Very simple pod watcher to watch for, look at NSM labels and create a service, a 10-point topology. And it takes a minute too. Any questions as we're waiting for this to go? Okay, so now we're going to go over here, and first thing I'm going to do is I'm going to grab the cluster IP that my little watcher program so this is the cluster IP. This is I pointed to my kind cluster here, which is also running on this node. Here's the cluster IP. So now if I...
So the thing that just ran before, that was the controller that would watch for NSM-enabled application pods and create a service entry in that kind cluster, and that causes a cluster IP to get created. And then it also, that watcher program also added endpoints for NSM IPs in there. So the Envoy rules now are going to be set up with a listener on that cluster IP and mapped to the NSM endpoints. So Istio will work in like that because of that.
And what you can see here is if you look at the pod name, the load balancing isn't always exactly round robin with Istio, but you can see it's actually load balancing across the different clusters.
So this means it's working.
You can clap now, and, you know.
It's sigh, maybe.
And so just back to the slides then. It's going to go back to the beginning. Just kind of, sorry, there's quite a bit of a latency. What?
Oh.
Oh, that's not good.
Did it die?
My application died.
So his application
Do you,
decided to go away. So the final, summary of what happened there, we ended up showing that Istio was able to function after we not only created that virtual L3 network between those pods, we had to integrate the Istio control plane with discovery of the NSM interfaces. So that's what that kind cluster and that program we call the watcher program, because it acts as a controller and notices NSM-enabled pods for clients, and then creates entries into the service API on that kind cluster. So we didn't have to modify Pilot at all to get that to work, because we had so we implemented before, and we're part of the Istio community, and Pilot has been enabled for a long time to be able to watch multiple clusters, and so we just reused that functionality.
you're not actually displaying.
But
Yeah. Anyway, so I think, I have I'll flash a final slide with references. We have all this in publicly available. You can duplicate these results. There really wasn't much other way in the way of slide deck. There wasn't really much other thing to say other than
thank you.
Thank you. And